Welcome to our group presentation. We are from Group 32, and in this video, we will be presenting our project titled Boeing 737 MAX Crashes. Allow me to first introduce our team members. The first member would be me, Neasha Nur Akila from Petroleum Engineering. The second member would be Muhammad Anur Akil from Mechanical Engineering. The third member would be Wan Nur Izhanis from Chemical Engineering. The fourth member would be Nurul Anas Muhammad Rizdi from Chemical Engineering. And the fifth member would be Faizal Abdul Hasbi from Electrical and Electronics Engineering. The Boeing 737 MAX crashes between late 2018 and early 2019, involving Lion Air Flight 610 and Ethiopian Airlines Flight 302, killed 346 people. The crashes raised questions about aircraft safety, engineering responsibility, and the role of regulators in protecting the public. The 737 MAX was designed to rival Airbus's A320neo, but Boeing made modifications to fit larger engines while retaining the original airframe design.
Lion Air Flight 610, a brand new Boeing 737 MAX 8, crashed into the Java Sea just 11 minutes after takeoff from Jakarta in 2018 and killed all 139 people on board. The aircraft experienced repeated, uncontrollable nose-down movement, and despite the pilot effort to return, they lost control at high speed. Just months later, Ethiopian Airline Flight 302, also a 737 MAX 8, crashed 6 minutes after departing Addis Ababa and route to Nairobi. This flight also suffered from uncommon nose-down input, resulting in death of all 157 people from 35 countries. Both crashes were linked to a flawed flight control software called MCAS, designed to prevent stall by adjusting the stabilizer based on data from a single angle of attack sensor. In both cases, faulty sensor data triggered MCAS repeatedly. Critically, neither airline had installed the optional AOA disagree alert system that could have warned the pilots. These twin tragedies exposed serious flaws in Boeing design and FAA oversight.
Next is the technical and engineering issues. There are three key issues that contributed to the Boeing 737 MAX tragedies. First, the erroneous activation of MCAS due to a faulty AOA sensor. MCAS relied on only one sensor, making it a single point of failure. In Lion Air Flight 610, a miscalibrated sensor triggered repeated nose-down commands, while in Ethiopian Flight 302, a suspected bird strike damaged the sensor, hence causing a similar outcome. Second, there were major engineering design flaws. The AOA disagree alert was not a standard feature, so pilots were warned about incorrect sensor data. MCAS could override pilot inputs without notice, hence violating the essential human-machine interface safety principles. Third, there was poor transparency and pilot training. MCAS wasn't disclosed in flight manuals or simulators. Pilots didn't know how the system worked or how to respond in failure scenarios.
Next, I would like to present the ethical reasons behind the failure of the Boeing 737 MAX. The first issue was unsafe system design and engineering negligence. Boeing MCAS relied on just one sensor and could override pilot control without warning. Despite knowing this risk, they didn't inform pilots or regulators. This violated Regulation 23, which requires engineers to prioritize public safety. Secondly, there were lapses in regulatory compliance and certifications. Boeing downplays the MCAS to avoid pilot simulator training, and the FAA relied heavily on Boeing's internal assessment. This violated Regulation 23(2)B, which emphasized honesty and full disclosure. Lastly, there was a failure in ethical culture and risk communication. Engineers raised concerns, but management ignored them due to pressure to cut costs and meet deadlines. This branch Regulation 23(2)A, which prohibits external pressure from influencing engineering decisions.
Hi, in this section, I will be presenting the 4 key recommendations to prevent future aviation disasters like the Boeing 737 MAX crashes. First, ethical decision-making must be reinforced. Boeing engineers were pressured to hide the MCAS safety issues, violating their duty to protect the public. Independent safety panels should be empowered to raise concerns without fear. Second, transparency in system changes is highly essential. Pilots weren't told about the MCAS system, leaving them unprepared. Thus, future design updates must be clearly communicated through training and manuals. Thirdly, certification must be truly independent. Boeing acted as both designer and regulator, creating conflict. Third-party reviews should be mandatory to ensure unbiased safety checks. Lastly, engineers who speak up must be protected. Protected reporting channels and whistleblower laws are key to encouraging responsible action.
The Boeing 737 MAX crashes highlighted significant flaws in aviation engineering and ethical practices. The MCAS system, which relied on a single sensor and lacked proper redundancy and warning systems, was faulty. Boeing's failure to communicate system changes and unchecked safety concerns further exacerbated the issues. These crashes serve as a reminder that engineering is not just about innovation, but also about responsibility. Engineers must prioritize human safety, challenge harmful methods, and operate with integrity. The Boeing 737 MAX case emphasized transparency, accountability, and public safety. As future engineers, it is our duty to learn from these failures and ensure safety, honesty, and ethics remain at the heart of our designs. By learning from these lessons, we can create safer and more responsible engineering practices for the future. That will be all from us. Thank you.